All right, we are starting on 6-8, which is graphing sine and cosine day 2. We're going to focus on reflections and vertical shifts, and then we'll get to the phase shift in another lecture. So we're on page 16 of your student note packet. We're going to do 16 and 17 together, and then the homework that matches this section, you guys are going to fill out the tables on pages 18 and 19 of your student note packet, and then do the graphs on graph paper. So just note that the way that we do the examples in lecture today are also going to be the way that you guys complete your homework assignment on the next set of pages 18 and 19 in your student note packet. Okay, so back to page 16, we've got a couple of things we're going to focus on before we get to actually graphing some examples. So let's start with the reflections here. We've got the graphs of sine and cosine. I've already given them to you. Remember that sine carries the ordered the key points, axis, max, axis, min, axis. Cosine starts at its max, goes to axis, min, axis, max. So if we know the order of the key points for sine and cosine, then it can be a little bit easier when we apply flips and transformations. So when we've got reflections, the graph of negative f of x is going to be flipped over the x-axis. Now, I will make a note here that when we're looking at sine and cosine, we're never going to have a flip over the y-axis. We're never going to have a negative on the inside with x. And the reason for that is actually at the bottom of this set of examples. So take a look. We're going to skip the graphs of sine and cosine for just a minute. And at the bottom it says, if you're given an equation with a negative inside the argument, we can use the odd-even identities to transform the equation before we graph. So cosine is what we call an even function. Anytime we've got a negative on the inside with x, we can actually pull it out and it goes away. And the reason is that negative on the inside would indicate a reflection over the y-axis. But if we look at the graph of cosine right above, the graph of cosine is symmetrical with respect to the y-axis. So if we were to flip the graph of cosine over the y-axis, it would be exactly the same. So cosine is even. The negative on the inside doesn't matter. We can just get rid of it. That comes from one of the identities. Similarly, sine, if we were to reflect sine over the y-axis, we would get the same graph as if we were graphing negative sine x, a reflection over the x instead. So we're really just going to focus on reflections over the x-axis. We'll apply the even or odd function properties if we need to in order to pull the negatives out or get rid of them depending on if we've got sine or cosine. Okay, so what does a reflection over the x-axis look like? Well, all that's going to do is it's going to change where we see the minimums and the maximums. So reflection of sine over the x-axis, all of the points on the sinusoidal axis are going to stay the same. The only thing we're going to be reflecting are the minimums and the maximums. So the maximum goes to the minimum goes to the maximum, and we have this graph as our curve for negative sine x. So the order of the key points for negative sine x just becomes axis min, axis max, axis. We're going to do the same thing for cosine. So the minimums go to maximums and the maximums go to minimums, but the places where we cross the sinusoidal axis are going to stay the same. That becomes our curve for negative cosine x. And so the order of the key points there, negative cosine x will start at its minimum, axis max, axis min. So we're just switching the minimum and maximums in the order of the key points if we've got a reflection over the x-axis. Okay, the next thing we're going to be looking at today is the vertical shift. So that occurs when we're adding or subtracting a number on the outside of our function, and that's going to change where the sinusoidal axis is. So instead of the sinusoidal axis sitting on the x-axis, the sinusoidal axis is going to become that vertical shift. We will graph the sinusoidal axis when we graph our functions, and we're going to use a dotted line to represent the sinusoidal axis. So this is how we're going to be filling out the work for your homework and the examples from here on out when we're graphing sine and cosine. We'll start with the sinusoidal axis or that vertical shift, get the amplitude, which is the number that sits in front of cosine or sine, and then find the maximum, the minimum, the frequency, the period, subinterval length. We'll list the first 5 key points, and then we'll start sketching, and we're always going to sketch 2 cycles of each graph. So you guys can take a minute. You can read examples A and B at the bottom of page 16. They're just kind of examples on how we're going to do 1, 2, 3 on the next page of the notes. This is just a reminder about what those key point orders are for sine and cosine. We always start on the axis, then go to max, axis, min, axis for sine, and then cosine will always start at its max, go down to the axis, down to the min axis, and then end at its maximum. So let's work through a couple of examples together, and then I'll have you guys try 3 on your own before you get started on your homework. So we've got this function 7 sine of negative 3x over 4. And the first thing we're going to do is we're going to pull that negative to the outside so that we can get the reflection that we want. So because sine is an odd function, we can pull the negative on the inside with the 3x over 4 out so that we've got a negative 7 on the outside. We're going to have a reflection over the x-axis. And then I am going to rewrite the inside like that, 3/4 x. Sometimes I think it's just easier to see in cases like that. One note here, because x is our variable and not theta, we're going to make sure that we are scaling everything along the x-axis in terms of radians and not degrees here. All right, so let's start with our vertical shift. We are always going to represent it as an equation of a line, specifically a horizontal line here. So there's actually no vertical shift. We're not adding or subtracting a number to the outside of our sine function here. So y is equal to 0. It's just the x-axis as usual. Now, amplitude is going to be the number we're multiplying on the outside by. We're going to make sure amplitude is always positive. We'll represent that negative reflection somewhere else, but our amplitude will always be positive here. So we're multiplying by 7, so our amplitude is 7. Now, to get the max, you can always take the sinusoidal axis, add the amplitude, and the min, always take the sinusoidal axis and subtract the amplitude. And if you do it in that order every single time, you'll always get the correct maximum and the correct minimum. Really matters more for minimum when we're subtracting. The frequency is the number on the inside of our sine or cosine function with x. In this case, our frequency is 3/4. The period is always the standard period divided by our frequency. Because we have x as our variable, the standard period we're going to represent as 2 pi instead of 360 degrees. This is going to get us 8 pi's over 3 as our period. Next, we've got to find the subinterval length because that's what we're counting by along the x-axis. To find the subinterval length, we take the period and we divide by 4. This is going to become 2 pi over 3. So we're going to be counting by 2 pi over 3. In order to get 2 full cycles, we need 2 periods of 8 pi over 3 radians. So we're going to need to get all the way to 16 pi's over 3 radians in order to get 2 full circles, or 2 full cycles. All right, the key points are the first 5 key points for our sine or cosine curve. So the way that I like to do this is I like to set up the ordered pairs first, and then I'll start filling in the blanks, and I'll usually start with either the x or y values and then go back and fill in the other ones. So let's think about the order of key points for sine. Sine is always going to start on the axis, go to its max, axis, min, axis. So let's start with the y values of these ordered pairs. The sinusoidal axis is 0, which means that the y value of our first key point is 0. Then we go up to our maximum. Our maximum we found was 7. Back to the sinusoidal axis, a y value there is 0. Our minimum is -7, and then we land back on the sinusoidal axis for our first full cycle. So I've got the y values of my ordered pairs. Next is just the x values. So today we're not shifting our graphs left or right. So our first x coordinate key point is always going to be 0 radians. And then we're going to be counting by the subinterval length. So 0 plus 2 pi over 3 gets us 2 pi over 3. And then add another 2 pi over 3. That's going to be a total of 4 pi's over 3. add another 2 pi over 3. That is going to give us 6 pi's over 3, or 2 pi. And then add another 2 pi over 3, that will give us 8 pi's over 3. So those are the first 5 x values of our key points as well. All right, I'm going to set up my axes here and then draw on the scale. You guys go ahead and do that as well, and then we'll graph this together. So I've drawn in my x and y axes. I've left a little bit of space to the left of the y-axis because we're going to get used to graphing one negative key point as well. That will come in handy for your test. And then I just scaled the y-axis by 2 so I can fit 7 and -7. And then I'm going to count every 3 tick marks along the x-axis. I'll use my subinterval length 2 pi over 3. So I'm going to finish this with you guys. We're going to start 2 pi over 3, add 2 pi over 3 to get 4 pi over 3, and then 6 pi over 3, 8 pi's over 3, 10 pi's over 3, 12 pi's over 3, 14 pi's over 3, 16 pi's over 3. Now this is 2 full cycles, so I'm going to star that. I could keep going, right? This is going to get us 18 pi's over 3. This is going to get us 20 pi's over 3. Also, 18 pi's over 3 can simplify. And then 22 pi's over 3 will be the last thing that can fit on this axis here. Now that's going to get us a little bit over 2 full cycles. We end at 16 pi over 3, but it's just nice to be able to get the practice of continuing the order of key points there. Okay, so let's plot this. I'm going to start on the y-axis at 0 degrees. 0 degrees, sine is on the sinusoidal axis. So sinusoidal axis in this case is the x-axis. When it's the x-axis, it's kind of hard to see if we drop a dotted line, but I'm going to put that in to represent the sinusoidal axis. All right, and then every subinterval length, we're going to follow the order of key points. So we go to our max, axis, min, axis, max, axis, min, axis. And that's where sine should end every cycle, is on the axis. So we know we did the order of key points correct there. And then I can keep going. I can continue this pattern, right? Max, axis, min. And I'm going to do that going backwards as well. So that -2 pi over 3 that I've got on the left side of the y-axis. At 0, we're at the axis. So that would mean we'd be going down to the minimum if we're following the order of key points there. I'm going to make sure that my curve is smooth, continuous, and that I go through the 2 endpoints that I graphed. Okay, 2 cycles. I did a little bit more than that, but 2 minimum there on your homework. Let's do one more together, and then you guys are going to try 3 on your own. Okay, so this function, we've got 2/3 cosine -5x minus 1/3. That's a lot. I'm going to first apply even and odd function properties in order to deal with the negative on the inside. So cosine is even, which means that we can rewrite this as just the cosine of 5x. Because cosine is symmetrical with respect to the y-axis, a reflection over the y-axis doesn't matter, so we can get rid of the negative there. So the sinusoidal axis, or that vertical shift, is what goes first. In this case, we're going down down 1/3 units. So the line y is equal to -1/3 is going to be our new sinusoidal axis. So this is the first example where we've seen a vertical shift. The sinusoidal axis is going to change. The amplitude is the number sitting in front of sine or cosine. In this case, we're multiplying cosine by 2/3. So our maximum, to find the maximum, we always take the sinusoidal axis and add the amplitude. So our maximum here is 1/3. The minimum is then the sinusoidal axis, always that first, minus the amplitude. So -3/3 or -1 is our minimum value here. If you always do the order that I've given you guys, the kind of this table, axis plus amplitude and axis minus amplitude, you'll always get the max and the min, no problems there. The frequency is the number on the inside with x, which is 5, which means that in the standard period of 2 pi radians, we would see this curve happen 5 times. There'd be 5 cycles of it over the course of 2 pi radians. The period is then 2 pi divided by the frequency. That doesn't simplify, it's just 2 pi over 5. The subinterval length is always the period divided by 4, and the subinterval length is what we're going to be counting along the x-axis by. So this is going to become pi over 10 as our subinterval length. We're going to be counting by pi over 10 along the x-axis. Just like I did the last example, I'm going to set up the ordered pairs first. Remember, these are the first 5 key points that we're going to graph. And if I think about the order of key points for cosine, cosine will always start at its max, then axis, min, axis, max. So let's fill out the point values that correspond to each of these things. So I'm going to start with the y values here. Our maximum we found was positive 1/3. The sinusoidal axis is negative 1/3. Our minimum is negative 1. Back to the sinusoidal axis at negative 1/3, and finally back to our maximum, which was 1/3. All right, next are going to be the x values of our key points. So for now, we're starting at 0. There's no phase shift today. So 0 degrees, 0 radians in this case. And we're going to be counting by the subinterval length. So my next key point happens at pi over 10. My next key point will happen at 2 pi over 10. 3 pi over 10 is next, 4 pi over 10, and that's where we're going to land with one full cycle of our function here for cosine. All right, let's scale these axes and then we'll go from there. Okay, so I've dropped my y-axis kind of somewhere not at the far left of the graph, so I can graph at least one negative point. And then I'm going to scale every 2 marks along the y-axis will be 1/3. And that's just so I can kind of spread my graph out, so it's not as flat looking as it would be if I scaled by a different value. Along the x-axis, I'm going to count with you guys. Remember, we're counting by the subinterval length, so every 3 tick marks is going to be a pi over 10. So that's pi over 10. And then 2 pi over 10, 3 pi over 10, 4 pi over 10, 5 pi over 10, 6 pi over 10, 7 pi's over 10, 8 pi's over 10, 9 pi's over 10, 11 pi's over 10, and I'm out of space. So what would actually be 4 full cycles though? Remember, our period is 2 pi over 5. So 2 cycles or 2 periods is going to be 4 pi over 5. So 4 pi over 5, this point right here, that's the point at which we've graphed 2 full cycles of our curve. So I'm going to have 2 more key points to the right of that, and that's okay. And then I'm going to go make sure that I've got a point on the other side of the y-axis as well. So negative pi over 10, looks like I can fit one more, negative 2 pi over 10. And then we're going to start plotting these points. So starting on the y-axis at 0, first thing I'm going to do actually is sketch in my sinusoidal axis. Because it's different, I can see it a little bit more clearly now. And that's going to be really important when I go to actually graph the points where we cross the sinusoidal axis. All right, so that's my sinusoidal axis. Now cosine always starts at its maximum. So at 0 radians, we're going to be maximum, and then every subinterval, we're going to have another key point. So pi over 10, we're sitting on the sinusoidal axis. So now I have a point on the dotted line instead of the x-axis. Our sinusoidal axis has changed. And then we're going to go down to our minimum, axis, maximum, axis, minimum, axis, maximum. Now we've hit 2 full cycles, but I can continue going with the pattern, axis, and then we'll end at a minimum here. Now to the left of the y-axis, if I'm continuing this pattern, negative pi over 10 will be a point on the sinusoidal axis, and negative pi over 5 is a minimum. So sketch this curve, smooth, continuous curve, no V shapes like absolute value, we want to make sure we've got nice curves, no sharp edges. And we're also going to make sure that we go through the endpoints correctly. So that endpoint on the far right of my graph and the far left, they're both minimum, so I want to make sure I don't go below those points. We're going to touch down to the minimum and then come back up. All right, so pause the video, and you guys are going to come back for the answer to 3 after you guys have filled all the information out and done 2 full cycles of the final answer for number 3 looks like this. We can rewrite the function, and I would, as this. Y is equal to negative 5 cosine 3 pi over 4x plus 4. Sometimes I think it's easier to see the shift when it happens at the end. So that's where we get the y is equal to 4, and then the amplitude is 5. And then this is a reflection of sine. So instead of starting at its sinusoidal axis, or cosine, instead of starting at its maximum, cosine will start at its minimum with the reflection. So that's why at 0 radians, our first point is the minimum, because we've reflected cosine over the sinusoidal axis here. All right, your homework then is going to start on pages 18 and 19 of the student note packet, where you guys are filling in all of this information, and then you guys are going to do the graphs separately on a piece of graph paper. Email me if you guys have questions.